Hello and welcome. I'm Josh, co-founder of Tala. We're creating a mini-series of conversations with some of the world's most inspiring voices in science, design, and lighting. In this episode, I'm joined by Professor Russell Foster for a conversation on how light shapes our sleep, health, and daily routines. We talk about circadian rhythms, what happens when our internal clocks fall out of sync, and some simple ways to sleep and feel better. So let's jump in. Today, I'm delighted to be joined by Professor Russell Foster. Russell, thank you so much for making the time to be with us today. Russell is Professor of Circadian Neuroscience at the University of Oxford and author of the acclaimed book, Lifetime. We've all been reading it here. It's an amazing book. It's packed full of insight, really great research. We sleep for 36% of our lives, so the more we can learn about this subject, the better, I think. So diving straight in,
well, just nice to join you, Josh.
Yeah,
thank you very much for that plug for the book.
My pleasure. It's been really fun to read. I particularly like all the quotes you've got at the start of every chapter. The quotes are amazing. So, diving in, what first drew you into this field? What makes the study of sleep and circadian rhythms so compelling?
Well, it's interesting you should ask me that, because my first degree was zoology. And I was a competitive swimmer. So I went to university thinking I'd be a marine biologist because I swam and I love biology. Then I discovered physiology and comparative physiology. And it was, which, at a time when I went to university, that was still taught. And it was how different groups of animals tackle and solve similar problems. And I just thought that was so cool, that diversity of biology and physiology. And during my third year, we were introduced to circadian rhythms. And I just thought it was so extraordinary that there is an internal biological clock tweaking up and down our heart rate, our metabolism, our ability to process information. And I just got hooked really at that early stage. And my PhD was not absolutely in circadian rhythms, but it was in rhythmic biology, which was how birds detect the increasing and decreasing day lengths to regulate their reproductive biology. And so that was kind of my way into the rhythmic world, fascination, and also, seasonal biology, which is, as I say, my way in.
Amazing. And for those new to the science, what exactly is a circadian rhythm and your body clock, and why does it matter so much?
Well, if we just step back a bit and think about what our biology needs to do, it has to deliver the right stuff at the right concentration to the right tissues and organs at the right time of day. And what the circadian system, this internal biological clock, does is provide that time structure for life. Why do we need it? Well, we need it to fine-tune our biology to the huge and varied demands of the light-dark cycle. Sitting on a planet that revolves once every 24 hours, we're exposed at one point to darkness and colder temperatures, and the other part to light and potentially higher temperatures. And our biology has to anticipate these transitions and adapt accordingly. And that's, essentially everything that we do is being fine-tuned by this internal clock.
Yeah, in the book, I loved your analogy of the internal clock, the SCN, as kind of the conductor at the orchestra. That really helped me kind of really understand what was going on there.
Well, I think that, yes. And of course, talking about the organization of our circadian system, I mean, mammals, we have this master clock within the base of the brain, the suprachiasmatic nuclei, the SCN. And it's regulated by light, and we'll come to that in a minute, I know. And then it sends out signals, which we originally, when I went into the field, we thought that this master clock forced rhythmicity on the rest of the body. And now we realize that every cell in the body has the capacity to generate a 24-hour oscillation. So it's coordinating the rhythms of billions and billions of individual oscillators, which are organized through the organ systems of the body, whether it be the liver, the gut, the muscles, and all the rest of it. And that's right. And so we've got this master conductor, and then all of these members of the orchestra taking their time cue from this SCN. and then aligning biology appropriately.
You know, you made a groundbreaking discovery that the eye has a third type of light receptor. Can you tell us a little bit more about that breakthrough and how it really changed how we understand light and sleep?
Yes. Well, I think we go back to my undergraduate days, and an appreciation that there were really weird photoreceptors out there. My third year undergraduate project was actually recording the electrical responses from the pineal organ of a tadpole. And I just thought that was amazing. You know, here's a non-eye light sensor which was regulating biology. And then my PhD work um, on a photoreceptor system was not in the eye, it was in the hypothalamus. I mean, can you imagine? There's actually enough light goes through the brain, reaches the hypothalamus, and then triggers that reproductive response. So I sort of grew up being aware of weird photoreceptors. Now, mammals don't have pineal or hypothalamic or photoreceptors other than in the eye. And we know this because if you cover the eyes, then the ability of mammals to regulate their clock to the light-dark cycle goes completely. And in us, for example, our body clock is slightly longer than 24 hours, so we'll get up a little bit later and later and later. And that's what happens to blind people, which we should talk about later on. And so we knew it was the eye, but my problem was, and again, I was very much influenced by my undergraduate professors, one of whom was a chap called John Lithgow, who wrote this incredible book, this will date me, in 1979, called The Ecology of Vision. But the central thesis was, you know, sensory systems are adapted to particular sensory tasks. And when you say that, it sounds kind of obvious. The problem I had was, how can the visual system, with this extraordinary ability to grab light in a fraction of a second and then forget it's seen it, to make an image of our world, also be used to measure light over relatively long periods of time, minutes and hours, so a measure of brightness at particular times of day. And these are such different light detecting tasks. I couldn't really see how the visual system, the classical visual system, could do it. And I didn't come from a visual background. I came from this weird comparative biology background. And so what we decided to do was a crazy experiment, and that was to take mice with hereditary retinal disorders. And these mice were being used to try and understand human eye disease, but they'd lost their rods and cones, their visual cells. And what was truly extraordinary is that these mice could regulate their biological clock with the same sensitivity as their normally sighted, you know, mates. And I just thought that was so extraordinary. In fact, as I speak, I can still feel the hairs on the back of my arms going up because it was such an extraordinary finding. And we then spent a decade really trying to nail that issue about, is this real? And the opposition was ferocious. The vision community, who don't think about these sorts of questions. I mean, I gave a talk in one place in the States, and one of the people stood up in the audience, and I thought they were asking me a question, and they just said bullshit and walked out. And another person I remember, again at the end of a seminar, said, "Are you seriously telling us that after 150 years of studying the eye, we've all missed a photoreceptor system?" And of course, I was much younger in those days and full of verve and vigor. And I sort of said, well, yes, I think you're wrong. And of course, we then had to get the data to support that. And ultimately, those early findings gave way to the final finding, which was that in addition to the rods and cones, there's a group of cells at the outer margin of the retina called the ganglion cells. And these are the cells that collect all the light information from the photoreceptors in the inner retina, and they send their axons into the brain. And those axons form the optic nerve. And what was truly extraordinary is about 1 out of every 100 of those cells is directly light sensitive. And that's the key way in which light-dark information is getting to the master clock within the brain. And yeah, it was, I have to say, there's a certain pleasure, because the people that were so critical of the vision community of these early results then gave me some rather nice prizes, which I value highly.
Good on you. I think
Yeah.
that's
But
amazing just to get a sense of your like actual eureka moment and then obviously having to
but
communicate and then go
but it
gather
was
the data.
interesting because when I had a wonderful mentor. The first studies were done in the States at the University of Virginia, and my chairman Michael Menaker was a brilliant man, absolutely brilliant man. And My first grant to the Eye Institute in the States was destroyed. I mean, just came back utterly unfundable. And I thought, oh well, that's the end of my career. And he called me to his office and said, "Dad, Mr. City, your data's great. You're right, they're wrong. Send it to another branch, another funding agency." And so I said, yeah, I changed 3 words. 6 months later, I got a call from these people, this new funding agency, saying, "Well, we'd like to congratulate you. Your grant has come top of the whole study section. We think it's so exciting, and would you mind if we copied it, took it to the Society for Neuroscience, which is this huge, great meeting, and sort of use it as an example of how a research grant could be written." Now, what better experience could you get than that as an early researcher, mid-career researcher, and you just convince you just keep on kicking the door until the buggers let you in,
I
and
love
that's what
that.
we did. Better and better data.
That's great. And, thinking about light, health, and longevity, I think in your book and in your research, you use this term SCARD, SCRD. What
Yeah.
does it mean, and why is that so important when we kind of think about sleep and work?
Yeah, well, it means sleep and circadian rhythm disruption. And the logic behind it is that it's now really because we're understanding how closely coupled the circadian system, the body clock, to the sleep systems, they're essentially indivisible in many ways. And it's difficult to know whether disruption originates from circadian rhythm disruption or sleep disruption. And so we've used it as a generic term to mean sleep and circadian rhythm disruption, SCARD. Now, there's also another reason we use the SCARD, because when we were writing a grant, there was a word limit. And sleep and circadian rhythm disruption can be compressed into a single word rather than four. And so it has a legitimate role, but it was also a slightly pragmatic one. So we could squeeze more words into the grant application.
Oh, love that. And, biologically, what happens when our circadian rhythm is misaligned?
Yes, well, of course, with misalignment of the clock, you also get misalignment of sleep, and that's why SCARD is such an important term. And we can think of the the problems impacting upon our emotional, our cognitive, and our physiological responses. So if we think about our emotions, if we're getting scarred, even short-term sleep circadian rhythm disruption, we see changes in our mood, our irritability, our anxiety, loss of empathy. I think a really interesting one, which is that you fail to pick up the social signals from your friends, colleague, family. You're just blunted emotionally. Um, Frustration, risk taking, another fascinating area. You do stupid and unreflective things. When you're tired, your circadian rhythm disrupted, let's say you're driving home after the night shift, then you think, oh yeah, I can get through the traffic lights before they turn red. No, 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 of course you can't. And you wouldn't think of it if you had a normally rested brain. The other really interesting area is what's called a negative salience. Some beautiful data has come out from Germany showing that the tired brain remembers negative experiences but forgets the positive ones. So one's whole worldview is, biased to negative, and therefore the decisions you make are all based upon negative experiences. So that's sort of our emotional responses. Our cognitive responses, our ability to process information just goes. I think we've all experienced this. I suspect you did during your finals, and I certainly did. And then you've also got the failure to consolidate memory, to concentrate, to communicate. Also, I think another really interesting area is to try and prioritize. So we're flooded with information, and what we normally have to do is say, okay, that's the important bit, and that's what I'll attend to. And when we're tired, we know it's all a big blur. There's just all this stuff coming in, and we can't tease apart what's important and what isn't. Um, as I say, creativity, productivity. I mean, the things that make us what we are, our ability to process information. and indeed to have a laugh. I mean, a sense of humor goes with SCARD. Longer term SCARD, it gets kind of serious. So long term night shift work is associated with increased cardiovascular disease, altered stress responses, which, elevated cortisol, for example. And one thing we know about elevated cortisol, it suppresses the immune system, which could be the underpinning of why infection is higher in individuals with SCARD and indeed cancer. A long-term night shift is associated with higher rates of cancer. So the World Health Organization has now designated night shift work as a probable carcinogen because of the high rates of cancer that you get in night shift nurses, for example, colorectal cancer, breast cancer, metabolic abnormalities, type 2 diabetes, obesity, and then a really important area, a whole domain, which is depression and psychosis. We've done a lot of work in this area, and if you are vulnerable to depression and psychosis, then poor sleep, SCARD, can shift you into that more dangerous zone. And studies that we've done in Oxford with colleagues in psychiatry have shown that if you can stabilize SCARD in individuals with paranoia and hallucinatory experiences, then you can actually reduce the severity of these conditions. So what started out as this curiosity-driven research now is providing us some new therapeutic approaches to mental health.
Yeah, I think the night shift element of your research in the book really hit home for me, because I remember growing up, my mum was a night shift worker in the NHS, and our whole family could kind of see the impact it was having on her long term. And we were really happy when she was lucky enough to retire and kind of put the night shifts behind her, because it's just it was interesting to read the actual effects on it in more detail.
Yeah, and there's some additional areas. I mean, our frontline staff, for example, if you're sleep deprived, then the efficacy of vaccination goes down. And of course, our frontline staff are sleep deprived, and they are the ones encountering all those pathogens. And so they really, we really must start to think about this. Our frontline staff are extremely vulnerable, and we can't get rid of night shift work, but we can make we can mitigate it. So vulnerability to infection as a result of the latest circulating bugs. Make sure that before vaccination they get a good night of sleep, and the following night. Studies have also showed that if you don't get a good night's sleep after vaccination, you can reduce the efficacy. So there's some really important issues here. I mean, we talked about obesity, metabolic abnormalities. What food is made available to our night shift staff? It's high fat, it's high sugar. We've made no provision to offer a healthy alternative. So yeah, night shift work is really serious, but we're not going to get rid of it. But what we can do is mitigate some of the problems. I mean, a very nice study recently showed that if you eat well and you exercise, you can reduce the chances of developing type 2 diabetes very, very markedly.
And one thing I picked up in your research is just how nuanced this subject is, and it's very easy to kind of oversimplify certain elements. And I think one of the through lines I picked up is what you were just saying before, of just being able to stabilize someone's sleep-wake cycle is so important. And I wanted to ask, why does having a consistent sleep routine kind of matter so much?
Yeah, I mean, this all fits into the sort of the box of cognitive behavioral therapy for insomnia, cognitive behavioral therapy, CTBI. What that stabilization does is give your clock the right time cues. So you're exposed to light at the same time, you're eating at the same time, you're socializing, you're exercising, and all these help consolidate. There are other things, of course, that are really key. I mean, most people don't have a sleep problem. It's an anxiety or a stress problem. And CBTI is also involved in trying to find ways of reducing that anxiety and stress prior to bedtime. So it's two things. It's consolidating, it's making an environment that's stable, that enhances the circadian system, but also the other limb of cognitive behavioral therapy for insomnia is finding ways to wind down and to relax.
And looking ahead to where the science is going, is there new research linking light and sleep to kind of healthy aging or reducing cognitive decline? Like, which kind of
Yes.
areas of research are you personally getting most excited about?
Well, I think so, there's a whole bunch of things going on, which is exciting. And many of us who started as zoologists or biologists, have gone through and we've sort of made these sorts of discoveries. We're now moving into the translational space. Now, for us, is that okay? So we've got those new photoreceptors, and we've worked out now what the signaling pathway is to the master clock within the brain. And what that has provided is a substrate for identifying drugs that can mimic the effects of light on the clock. Now, why would you want to do that when you can go outside and just get your light dark cycle? Well, of course, if you've lost your eyes, and I work closely with Blind Veterans UK, those individuals have a double whammy. They are both visually blind, but they're also time blind. And it's very interesting chatting to these individuals. They say, look, I can kind of cope with not being able to see. What I can't cope with is my body completely fooling me about what time of day it is. And one chap told me that he had lost his eyes and he was determined to try and normalize life as much as possible. And he was determined not to have the untidy front lawn. And so he'd worked out a way of getting the mower out the garage, how to run it up and down the front lawn. Couldn't see it, but he could sort of tell when it had reached the edge and he could turn it round. So he was doing this. And in the middle of this, his wife came down and tapped him on the shoulder and said, "It's 3 o'clock in the morning. You're waking the neighbours." And how does here's somebody who's trying their very best to normalize their life, and yet uh, it's being shattered by, as they say, my body fooling me. And it can cause huge depression and poor health. And so what we're excited about is developing drugs, and we've done all the preclinical trials on mice. We've now shown that this drug works in humans. It's safe in humans, and we now want to do the clinical trials showing that we can give this drug on a daily basis, a tablet, which will then mimic the effects of light on the clock and give these individuals back a sense of time. And I think that's just incredibly exciting. And that's work in progress. It's not available yet, but we're working in other drugs as well. But of course, I think it's more than just the blind. I mean, what we've shown, for example, in schizophrenia, in neurodegenerative diseases, and indeed neurodevelopmental conditions, it's very difficult to stabilize the circadian system with light dark exposure. And I think what I envisage is that we could give this drug for a short period of time, stabilize the clock, and then wean people onto a very robust light dark cycle. So I think it has application outside of just the blind. So that's one area that we're working on. Other areas, some fascinating work from colleagues in the States have shown that when you have a cancer cell, the clock is turned off. And so what a cancer cell does is divide very, very rapidly. What the circadian clock normally does is turn that rapidly dividing cell into dividing once a day at an appropriate time. And all the most of the cells of the body have a circadian-driven division cycle. Liver, for example, is the classic example. But cancer cells have no clock. And what he's doing is trying to reintroduce the clock, the molecular clockwork, into a cancer cell to convert it back into a normal cell so it doesn't undergo rapid cell division, and which is the nature of cancer. Now, it's again early days, but boy, that would be absolutely fantastic. So there's lots of it's really, I think it's so fascinating because the field, as I've sort of intimated, started with people working on mice, on squirrels, on pigeons and reptiles and plants, all meeting at these meetings. And now we're using this fundamental knowledge that's been acquired over the past 30 years to genuinely transform healthcare. I mean, a big push we're trying to develop in Oxford is a Centre for Circadian Health, because we want to introduce either known science, so when you take your anti-cancer drug, will have a big effect upon your long-term survival. Studies that came again from the States showed that a cocktail of drugs used to fight breast cancer would over 5 years would lead to 45% survival, but at a different time of day that would drop to 10% survival. In childhood leukemia, one time of day led to 70% survival over 6.5 years. The other group, 30% survival. So these are big effects. We've got to embed that knowledge into mainstream medicine. When you take your antihypertensives, is probably going to have a big effect upon your chances of having a stroke. When you take aspirin, when you take so many different sorts of drugs, will have a time of day effect. No great surprise in what we said earlier, which is that everything changes across the 24-hour day, our biology. So clearly drugs are going to have a different effect. That hasn't been introduced to mainstream medicine. And as I say, I'm working very closely with my clinical colleagues to try and establish this Centre for Circadian Health, whereby we can get this knowledge out there and develop new knowledge to improve our chances of making better use of the therapeutics we've got.
That is fascinating, both from seeing the progress of where the fields come from, and then just the breadth of where it can go. And one thing we wanted to discuss was kind of thinking, at a day-to-day level as well, the impacts of light, and for our listeners, thinking about morning light and the simple how to optimize how we wake up.
Yes.
Why is exposure to morning light so crucial to our bodies and minds?
Yeah, I think the whole area of artificial lighting and of architecture is so incredibly important. I mean, I've had the opportunity of talking to lots of architects. Some who say, "Oh, natural light, oh God, it's just a pain," and others who say, "Well, I'm going to optimize natural light input, and where natural light can't do it, I'll then have human-centric lighting to kick in." And so there's this really huge interest at the moment in getting the right sort of lighting in our built spaces. Because after all, if you think about it, in 1800, 95% of us worked outside. And then over the past 225 years, we've essentially moved into dim, dark spaces. And I would urge your listeners to download a lux meter onto their smartphone and just get a sense of the variety of light that we encounter, how little inside versus outside. Okay, so why is light important? I will finally get there. So when we see light matters. Morning light advances the clock, so it makes us get up earlier and go to bed earlier. Dusk light delays the clock. We go to bed later and get up later. And we did a study on university students all over the world a few years ago, and we matched their chronotype, their morningness and their eveningness, with when they saw light. And what was so fascinating is all the late types were sleeping through the morning and morning light, which would advance the clock, make them get up earlier, but they were getting late afternoon, early evening light, which would push the clock later. And so, light in that sense is really important. Why morning light is so important is that for most of us, we have a longer body clock, a little bit more than 24 hours. So we have this tendency to get up a bit later and later and later. And so what daily light exposure does is nudge the clock forward on a daily basis so that we're aligned to the outside world. And so getting, as I call it, that photon shower in the morning is so very, very critical. Now, dusk light is more complicated in that there's quite a bit of misinformation out there about dusk light. So you'll read that if you look at a Kindle before you go to bed, then it's going to delay your clock and make you get up much later. It's going to disrupt your sleep-wake pattern. Well, we need to dissect those data. And the experiment that was undertaken that forms the basis of all this was getting people to read a Kindle for 4 hours on its brightest setting on 5 consecutive nights. And during the experimental period, everybody was kept under about 90 lux, so really quite dim light, and then exposed to Kindle light for 4 hours before they went to sleep. That delayed sleep onset by 9 minutes, and it was just statistically significant. Melatonin was affected, but this is all part of the confusion because melatonin is not a sleep hormone. It's a modulator of sleep, but we saw from those data that actually it was only delayed by 9 minutes. And what's more, the experiment was repeated a few years later by a Scandinavian group, and rather than keeping people in the lab under 90 lux, they got, I think it was 500 to 600 lux for 6 hours. That abolished all the subtle effects, both melatonin and delayed sleep, with looking at a Kindle. And so some of the advice that sits out there is based upon lab-based studies, not real-world studies. So morning light advances the clock, evening light delays the clock, but light during the day will have an effect upon the sensitivity of the clock that evening. So if you're in darkness during the day, then you will be more sensitive to light in the evening, and that's more likely to shift you to a later time. And so light is incredibly important. I mean, just as an aside, some interesting studies on teenagers, and what was going on with teenagers is that, of course, they were getting, they weren't over the weekend, for example, they were massively oversleeping. So they were missing the morning light, but then out in the afternoon, early evening, and that was shifting the clock later. So when Monday morning came around, it was much more difficult to get up. So as boring as it is, you've got to keep up regular exposure to the light-dark cycle. And teenagers traditionally short sleep during the week, massive extended sleeps over the weekend, but that really sets them up badly for the week to come.
Yeah, that makes sense. And the screens in the evening, it is becoming more colloquial to try and avoid screens before bed. That's really interesting to hear about the kind of Kindle research there and how there's so much nuance.
And indeed, the efflux systems and the screen shift, there's no data that has any effect whatsoever. Now, I think there is an impact of smartphones and technology before you go to bed, but it's not necessarily the light, it's the alerting effect the social media, the endless emails and all the rest of it have. That's the danger, that's the real problem. But if lights are relatively dim in the evening, it's fine. And some really unhelpful advice has gone out saying, well, you shouldn't see more than 30 lux for 2 hours before going to bed. Now that's really dim light. And if you're an elderly person, the chances of falling or tripping under those dim light far exceed any likely sleep disruption that you might have. So in fact, I'm chairing a group as part of a government advisory group on what do we know about the impact of artificial light and light on human health. And so we're going to try and pull the data together to understand what we actually know and what we need to know to provide evidence-based guidelines, because I think it's a bit of a mess at the moment. We haven't got a clear message, and I think I blame my tribe. The scientists haven't been that helpful. We've got to get a clear message out there so we can develop evidence-based guidelines to say, well, this is ideally what you have. So, first thing in the morning in the office space, it should be brighter light. This will increase alertness. This will also sort of set the clock. And then, well, what should we have in the evenings at home? And how does it differ between an elderly person and a young person? And there are differences. So we're trying to tease apart the intensity of the light, the duration of the light, the wavelength of the light, your light history, your age. All of those things need to be factored in to give some proper guidelines. And we're not there yet. And as I say, sometimes I'm embarrassed by some of the statements I read.
And thinking kind of even beyond light in the evening, what do calming kind of rituals or even nature sounds,
Yeah.
Do they play a role in helping the brain kind of transition into it's more smoothly into sleep?
Absolutely. I think we've just sort of said most people don't have a sleep issue; they have an anxiety or a stress issue. So that's part of it. But also, the transition from the biological wake state to the sleep state is complex and involves a complete realignment. So you can't just assume you can switch from one to the other. And as you point out, a winding down process can be extremely useful. And that can be in a variety of different ways. I mean, immediately after work, going to the gym, going to the pool, burning off that sort of built up anxiety from the workspace, and then getting home, relaxing, listening to music that is appropriate, not doing necessarily violent video games, or watching some of the horror films that seem to dominate the TV these days.
Avoiding the dopamine hits.
Yeah, I mean it's yes, absolutely, and it's about winding down and appreciating a transition, and making the sleep space a haven for sleep. And of course, one of the great problems that we had during COVID is that everybody's bedroom was turned into an office, and that's still the case. And I know personally that if you're trying to get to sleep and you can see a little light going on the computer or something, it's a reminder of the demands of work and all the stuff you've got to do. You've got to get that stuff out and define this as a place to sleep. Dark, relatively cool, not too hot. And there's a very interesting sex difference. Women tend to want a warmer bedroom than men. They have a slightly higher temperature than men. And that seems to be because men's bodies on average, I mean, don't look at me, tend to be less fat and more muscle than women. And of course, muscle has a higher metabolic rate, so they generate more heat compared to most women. That's a generalization. But I remember going to northwest Australia, the Pilbara, the mining district, and this lady said to me, this fan has saved our marriage because it's turned on to her husband on one side of the bed, and she gets a much warmer side of the bed. So there are differences that one needs to work out, but ideally the bedroom should be this place, this where you relax and you see.
And I'd love to kind of bring it all together with some practical takeaways for our listeners. What are some simple daily routines, in the morning, work day, evening, that you'd recommend for better sleep and energy?
Well, the good thing is there's lots of things that we can do to improve our sleep. I think many people feel that sleep is what you get and you have no control over it. It's a flexible, dynamic behavior, and we can do lots of different sorts of things. I mean, if we divide it up as during the day, before bed, the bedroom itself, and when you're in bed, we've talked about the importance of morning light and getting out there to get that photon shower. One thing during the day is napping. Now, I have mixed views about napping. So if you feel the overwhelming need to nap during the day, you're probably not getting sufficient sleep at night, and you need to address that in some way. And as long as the nap is not longer than 20 minutes or so, all the data suggests that, a nap around lunchtime can improve your cognitive performance during the second half of the day. And many companies actually, have taken this on board with napping pods. The problem with naps is that, and again, going back to teenagers, is that if you get very shortened nighttime sleep, they're struggling through the school day, really, and teachers, often report they're falling asleep actually at desks. They get home in the afternoon, then have a 2-hour sleep, which pushes back the sleep pressure, meaning it's more difficult to get to sleep that night. So you can fall into a vicious circle of shorter nighttime sleep, longer daytime naps, which means that you don't function, for most of the day. So be careful about napping. Of course, exercise, that's great because it's consolidating, our behavior, and if you run outside in the morning, you can combine your photon shower with your morning exercise. I think absolutely key, avoid excessive consumption of coffee and tea after 2 or 3 o'clock in the afternoon. Some people, including myself, are very sensitive to caffeine, and a 4 o'clock cup of coffee will delay my sleep onset that night. And in our household, decaf tea, decaf coffee in the afternoon and the evening is what we do. Um, and again, coming back to this critically important thing at the end of the day, step back from stressful situations as much as you can. And that may be mindfulness. It can be anything that works for you, listening to a favorite bit of music, whatever. I have to say that I used to be very rude about mindfulness, and I apologize now, abjectly. I thought I had it in the same box as crystal waving in the early days. But actually, as a relaxation technique, it's been shown to be extremely effective for winding down and getting better sleep. So it's worth. I mean, things like yoga too, gentle yoga.
And you're right. I think these topics like creating rituals and mindfulness, they have sometimes always been put in the bucket of, oh, that's not really scientific. That's nothing. But now it's interesting to start seeing the actual effects of having a wind down routine that you can kind of stick to. It's great to see that kind of transferring over into the world of, evidenceable science.
Yes, exactly. Yeah, you're absolutely right, Josh. So before bed, we've talked about light. I mean, I've said, standard kind of lighting is probably fine, but don't make it too bright. So, I don't want people to go over 300 lux, 200 lux, and so be careful about light. It shouldn't be too bright because it will delay the clock and make you get up. But most devices won't have an effect. The problem about devices, as we've touched on, is that they will have an alerting effect. Social media is, the death of sleep. Get those devices out, wind down before bedtime, and get them out of the way. Don't use sedatives, sleeping tablets, or alcohol to sedate yourself on a routine basis. They are sedatives, and in fact they can disrupt really important things going on in the brain. So alcohol is a classic one. You can disrupt memory formation, and you can disrupt sleep really quite considerably with alcohol. So be very careful. Antihistamines. I mean, there's some antihistamines. There's one called Phenergan, which you can buy over the counter. And I heard about this, and I thought, well, I'll give it a go, as you do. And I took it on a Friday, and most of the next day I was drowsy. So be very careful about these sorts of sedatives. Occasional use, of course, and your GP can advise you on this, and will probably only give you a short course of sedatives, just to stabilize things. Then you want to use behavioral methods. A good one in my household is the avoidance of stressful topics when you're in bed. So this, of course, is the time when most people actually have time to speak to each other with all of the pressures of work and all the other stuff. The important topics that you need, like finances and stuff like that. You're lying there, and the temptation is then to start talking about them. And as I say, our household, we've absolutely forbidden the discussion of family finances. You do that at another time, but you don't do it before you go to bed.
I respect that. I think that. Yeah.
And so it's again all that part of that winding down before bed. Make sure the bedroom isn't too hot. Part of sleep initiation is a drop in core body temperature, and so if the bedroom's too hot, it can be more difficult to do that. Some people love a hot bedroom, and that can be a slight problem because it'll take longer to get off to sleep. Obviously, keep it quiet. If you're living in a noisy apartment and all the rest of it, noise cancelling headphones and things like that can be useful. Keep it dark. The reason for that is light from outside can increase levels of alertness. And there's some very interesting study just published on artificial light at night and a higher risk of coronary heart disease. I've been quite critical of some of these studies because what they've done is measured light in an environment using satellites. This study actually measured individual light exposure in large numbers over a long period of time and showed that light coming in from outside or leaving the bedroom light on, for example, can be associated with negative consequences on health. We've touched on this. Remove TVs, computers as much as you possibly can. Again, it's about making the bedroom a place for sleep, not work. Don't clock watch. Many people have an illuminated clock by the bed, and you can glance at it and say, oh God, I've got to be up in 7 hours. I've got to get to sleep. And that can produce anxiety. And of course, if you wake up in the middle of the night and you see, it's 3 a.m., you think, oh God, the alarm's going to go up in 2 hours. I may as well just give up and start doing emails and drinking coffee. It's when the alarm goes off that matters, not how.
Otherwise, it's triggering. Yeah.
Yeah, and so don't worry about the exact time.
Oh, sorry, go on.
No, carry on, Josh.
I was going to say, if thinking about some of our listeners in the design community, if you could ask architects and interior designers to make one widespread change in how we design our homes and spaces and bedrooms for better sleep, what would that be if you could speak to all the architects and interior designers?
Well, do you mean just in the bedroom, or in the house generally?
I think the house, maybe twofold, house and bedroom.
So it would ideally be very dynamic lighting. So in the morning, you've got your bright light, increases alertness, sets the clock, and towards the evening, there'd be a more calming, dimmer light. I think one of the great ironies is what's the last thing that most of us do before we go to bed? We stand in the most brightly lit room, looking into an illuminated mirror while we clean our teeth. That's bright light. And certainly I have a mirror at home, which I can switch to the dim red light setting in the evening, which is what I do. And I think that kind of simple technology is really very valuable. But optimizing light exposure during the first half of the day, during the day, but winding down in terms of the light in the evening. Obviously, you don't want to shift the clock, but also you want to reduce alertness, and the brighter the light, the higher the levels of alertness, which will delay sleep onset. Another factor that I think one has to take seriously, and I know that your generation loves these devices, which is sleep apps, sleep watches, sleep rings, and all the rest of it. Don't take them too seriously. Most of them provide a pretty inaccurate representation of sleep. They're good for telling you roughly when you went to sleep and when you woke up, but when they try and define you had a really good night's sleep or a bad night's sleep, or you've got to get more slow wave sleep, or you didn't get any slow wave sleep, that's when they begin to fall apart, and they can genuinely increase levels of anxiety. I mean, I've had people coming up to me and said, my app tells me I'm not getting any slow wave sleep, or I'm not getting enough sleep. And I said, well, they're not accurate, and you really shouldn't worry about it. And they said, no, what I do, I set the alarm for 3 o'clock in the morning to wake myself up to see how much slow wave sleep I've actually had. It's that kind of, paranoia that you can sort of generate. And so they will get better with AI. They're going to get accurate, but they're not at the moment. So don't take them too seriously. And then finally, in bed. We've talked about routine. That's important. Go to bed, get up at the same time. Ideally, make sure the bed is large enough and comfortable enough. You've got the right pillows. Dim bedside lamps so you're not increasing alertness. Now, a really important one, which I'm asked about a lot, is what do I do if my partner snores? Many people can't tolerate earplugs. And as long as you've checked that your partner doesn't have obstructive sleep apnea, which should be taken very seriously, and that's basically a very loud snoring, then a cessation of breathing, and there's a quiet, and then a great big spluttering as people wake up. And that's because the musculature in the throat and the neck relaxes, blocks the airway. The brain detects it's being deprived of oxygen and then wakes you up. Then you get a huge blood pressure surge, which can damage small vasculature in the eye, for example, or the brain. Higher rates of dementia are associated with obstructive sleep apnea. So as long as it's not that, and that can be sorted out very easily with CPAP, I mean really easily. So what do you do if your partner snores? Well, then you find an alternative sleeping space. And when I suggested this, particularly to elderly couples, they say, no, it's the beginning of the end of one's relationship. I couldn't do that. I've suffered his snoring for most of my life. Well, there's no need to. And in fact, it's the beginning of a new relationship where you sleep better. One of the partners doesn't have bruised ribs. You're more empathetic. You have a better sense of humor, and you can make it into a ritual. You know what you do, who gets the tea in the morning, and that kind of stuff. So you don't have to suffer snorers. And another key thing is, if you wake, then stay calm. There's a strong argument that the human sleep pattern is not a single block of, let's say, 8 hours, but it's been called biphasic, where you go to sleep, you wake up for a bit, you go back to sleep again, or polyphasic, where you have a series of wake-ups and going back to sleep at night. So, for example, social scientists, historians have looked at the pre-industrial literature, and people often talked about a wonderful first sleep. There's French doctors who talk about the great advantages of doing certain things after your first sleep. And so, again, don't worry about it. Don't look at the clock. Just do something that relaxes you. And that can be a whole range of different things. You may want to leave the bed, a few pages of Jane Austen, whatever, relaxes you. For me, I listen to Radio 4 Extra, and if it's an episode of In Our Time on Chinese porcelain, I'm away in about 5 minutes. I love that program, but it's just so unthreatening and relaxing that I get back to sleep usually within 5 minutes. And if I'm listening to a play, I have to retune in the next morning to find out what's gone on. So I think those are some of the tips, but it's above all, do what works for you and then stick to it. And don't be bullied into having to go to bed late or getting up, early or whatever. Try and find the sleep pattern that works for you.
Yeah, that's really fascinating. And I really liked your comments there about kind of the broader kind of sleep tech market right now. There does seem to be a lot of complexity. Maybe the measurements aren't all perfect yet. It still feels quite early. We definitely see that as a design brand, we're kind of looking at that being like, how can we strip out complexity and make this simple so that someone can find, their own ritual and their own schedule that's based on fairly simple procedures to get into healthier habits.
Yeah, and the key thing is usually your sleep-wake timing and your sleep-wake duration, and the technology is good for that. And in a sense, I think adding on, trying to extract all this other information is unhelpful and misleading.
And the thinking of light almost as like a medicine, and we've talked about light's impact on your circadian system. If someone had to make just kind of one change to their daily light habits or thinking about light on a daily basis, what would you say that one change should be?
Well, I get that morning photon shower, certainly. Get outside if you possibly can. And the advantage of getting outside as well is because, of course, you need vitamin D. And normal glass will block UVB light, which means that you're not getting the levels of UVB that you need to synthesize vitamin D. And so, yes, sit by a window. If you can't get outside, absolutely, or increase the light with artificial light and LEDs, and there's lots of wonderful devices these days. But be aware that's not enough. You need to make sure you're getting vitamin D. So you may need to take a vitamin D3 supplement.
That's great. And Russell, this has been such a brilliant conversation. Thank you so much for your time today. I think a lot of us will hopefully walk away with a much deeper respect for sleep, light, and some of the simple things we can do to feel and perform a bit better every day. So it's been a real privilege to speak with you today, Russell.
Great pleasure, Josh. As I say, you make it very easy. I mean, the key thing is to embrace sleep. The analogy I made, the other day was so many people think of sleep as this sort of rather vicious animal that needs to be subdued and bludgeoned into submission. Whereas in reality, it's just a very cuddly teddy that you need to embrace and take to bed with you.
Love that. Thanks, Russell.
Great pleasure. Take care.
Thank you.
Bye-bye.
Bye. Bye.